In the previous video, we saw the things to determine if a chemical reaction has taken place. So that could be a change in the temperature or the color or the state, or there could be evolution of gas. And then we also saw how we can write chemical equations. So if we have magnesium ribbon burning in fire, and that gives magnesium oxide. So what we write is Mg magnesium plus oxygen gives magnesium oxide. Now here it's not balanced, it's a skeletal equation because it's not balanced. So we balance it by writing 2 Mg here. We write 2 Mg and 2 MgO, because there's before we write 2, what happens is we have an extra O, because there's only one O here and there's a O2. So what we do is we balance the equation and we get it same on the both sides, because mass can neither be destroyed and nor be created, right? Okay, now in this video we will be doing the types of chemical reactions. There are 5 types of chemical reactions. Okay, there are 5 types, but in this video we will be only covering 2, which is going to be a combination reaction and displacement reaction. In combination reaction, what happens, there are 2 or more reactants. Okay, there are 2 or more reactants which form or which combine to form only one product. Okay, now that could be, say, A and B combine to form AB. They together combine to form AB. Let's take the magnesium example again. 2MgO plus O2 gives 2MgO. Here what is happening? The magnesium and the oxygen are combining together to give me magnesium oxide. Okay, so this is combination reaction. We can say magnesium oxide is produced through combination reaction. These combination reactions, well, they combine obviously, and they are also exothermic. Okay, what exothermic means, that if you remember that there is an experiment in which we take in which we take quicklime, which is CaO, calcium oxide, in water, H2O, and we get CaOH twice. This is slaked lime. Okay, CaOH twice is slaked lime, CaO is quick lime. I can write them down. So this is quick lime and this is slaked lime. Slaked lime. Okay, and this is water. Obviously it's water. Okay, now here what happens is, after this reaction, here there is a lot of heat forming. When heat is outside, like it comes out or produced, it is known as exothermic. Thermic is heat. Okay, so exo means out and endo means in. So endothermic means it takes heat in, and exothermic, it means that it gives heat out. And so this, I'll write them down properly. So I have calcium oxide, quick lime, plus H2O, water, gives me calcium hydroxide, CaOH twice, or slaked lime. So these are 2 things which we have to remember, and this is all in general point of view, because if you notice, in magnesium oxide there is no heat forming. Okay, so when this magnesium oxide reaction does not come under endothermic, but uh, but generally all combination reactions are exothermic. Next, let us clear this place and kick out combination reaction and get in decomposition reaction. Decomposition reaction is completely opposite. Opposite to what? Opposite to, well, combination reaction, of course, what we learned right now. Now here what happens is, there's one reactant gives me 2 or more products. Okay, that's very interesting. Okay, so, or we can write, one reactant decomposes. Oops, Instead, decomposes better. Decomposes into, but this is here, decomposes into two or more products. Okay. And also I told you that combination reactions are exothermic. If you have guessed it, yes, these reactions are all endothermic. Endothermic. Okay, so let me give you three examples. First, we have silver bromide, AgBr, and that decomposes under sunlight, okay, some type of energy, to give me silver and bromide or bromine. So that is Br2. Okay, and next one, we can balance this real quick, like 2AgBr and 2Ag. Next, let us take another example, FeSO4, ferrous sulfate. Okay, this is called ferrous sulfate. In this, it is when it's exposed to heat, it gives me Fe2O3, which is ferric oxide, plus SO2 plus SO3. SO2 is SO2 is sulfur dioxide and SO3 is sulfur trioxide. So here it is forming three products. Okay, it's decomposing into three products. Here it's decomposing into two products. Okay, now let me quickly balance it out. There we go. And the is last one is water. Okay, H2O. So water needs electricity to split into H, hydrogen and oxygen. Now, okay, maybe I'll show you the balancing with a different color here. Okay, so that will be easier. So that could be this is 2 here and a 2 here, because there is 2 oxygens, there is 1 oxygen, there are 2 hydrogens, and when we put a 2 here it becomes 4, so we put a 4 there. Now notice all the energy provided are in different forms. Here it's sunlight, here it's heat, and here it's electricity. So these things are given different names as well. When there is sun involved, it is known as photochemical. Okay, because if you remember, photosynthesis is the process by which plants create food in the presence of sunlight. So photo basically means sunlight, so that's why it's called photochemical. Heat is known as thermal. So thermal decomposition, photochemical decomposition, there'll be a decomposition at the back. And then there is electricity. The electricity one is called electrolytic. So now here these are three equations, or you can say reactions, for different energies. Okay, so in exams, if they ask you, write the different examples for all the three types of decomposition reactions, you can write these three, or there are many more in the textbook as well. Okay, there are endothermic, they decompose, that means from one reactant, which is AB, they become A and B. So you can see they're completely opposite to uh, to combination reactions. Here they take in heat. When they take in heat, that means they are endothermic, and in combination reactions it takes out heat, that means it's exothermic. And here one reactant AB gives A plus B, two or more products, and then in combination reaction we have A plus B, which gives AB.